Hi there, my name's Bruce Rain from Brankus Creations, and in this video I'll be testing out the CREALITY CR-SCAN Ferret Pro 3D scanner. I've always been fascinated by 3D scanning, especially when paired with a 3D printer, where you can theoretically create a 3D photocopier. Back in 2004, I designed a DIY 3D scanner using a turntable, a digital camera, a laser level, and some software I wrote called ScanZ. The results weren't spectacular, but they weren't too bad considering the low cost of setting it up. If you'd like to know more about the ScanZ project, there are links in the description. I remember a time when professional 3D scanners were so expensive, the sellers didn't even list the pricing on their websites. These days, 3D scanning technology is far more accessible with products like the CR-SCAN Ferret and Ferret Pro. Here is the CREALITY CR-SCAN Ferret Pro. So let's see what is in the box. And oh, I like the look of that. Lovely little case there. Okay, so we have got a little quick start guide there. Enough information to get going. After sales service card. And some bits. And I'll have a look at this first. I see that we've got, it looks like a section here of cables. That's a big chunky cable, that one. And we have some little white marker dots. I'm sure that will become relevant when we start scanning. There's another cable. So there's 1, 2, 3, 4 different types of cable there. And a little USB-C to USB-A adapter. And then we have here, this is in a little plastic bag. And that, I dare say, is the scanner itself. And always love doing this. Yeah. And we have another little plastic baggie here. And there's a thing. So we'll find out more about this thing as we go. I accept that I have got a significant learning curve here ahead of me. And there's a really nice looking handle, and it's got some weight to it, so I suspect that's probably a battery pack. I think that's probably got a battery inside it, because just based on the weight of it. And that looks like some little foots, a trivet or tripod. Yeah, so that's quite nifty. And then two different types of, so that one there looks like it's designed, yeah, that's designed to hold the phone. That's the phone, and this one I think is clearly designed to hold the scanner. So that's what is in this lovely little package, and I have to say I love this, and this is obviously a great way to store it and keep it safe. This is the Ferret Pro. This top section is the 3D scanner itself. If you purchase the Ferret rather than the Ferret Pro, you basically get this top scanner part, a phone holder, and a power bank handle which doubles as a stand. The Ferret can be used with a computer, laptop, or Android phone, but not an iPhone. The Ferret SE comes with the scanner and a handle, but the handle is not a power bank. The Ferret SE can be used with a computer or laptop, but not with a smartphone. The Ferret Pro provides the scanner, phone holder, a battery bank handle, and this Wi-Fi module. In order to use the Ferret scanner with your iPhone, you'll need to connect to the scanner via Wi-Fi using this module. To connect the Ferret Pro to an Android phone with USB-C, use this supplied splitter cable. Connect the USB-A to the handle power bank, the L-shaped USB-C connector plugs into the Ferret scanner, and the middle USB-C connector plugs into your Android phone. To connect the Ferret Pro to an iPhone, plug the USB-A end of this little cable to the handle power bank, and the USB-C end to the underside of the Wi-Fi module. Then plug the USB-A end of this slightly longer cable to the top of the Wi-Fi module, and the L-shaped USB-C connector plugs into the Ferret scanner.
Once the Wi-Fi module light shines blue, you can connect the Ferret Wi-Fi signal with your iPhone. If scanning directly onto a desktop or laptop computer, you won't need the power bank, the phone holder, or the Wi-Fi bridge. You can plug the Ferret directly to your computer using the supplied 2-meter USB-A to USB-C cable. Looking at the scanner itself, you can see 4 little circles. This one here is the visible light camera. This captures the surface map of objects you scan and is also used for detecting markers, which we'll discuss in a moment. In the middle is the infrared emitter, and these 2 circles on the outside are the infrared sensors. The 3D scanning is achieved using a technology called LiDAR. This is the same technology used for facial recognition on modern smartphones. If we look at the scanner through an infrared filter, you can clearly see the LiDAR doing its thing. If you look at the pattern emitted by the scanner, it's not symmetrical. It's more of a random stochastic pattern, like what you would see if you looked at an inkjet printout through a magnifying glass. The scanner captures data in frames. Each time you see that pattern flash, this is 1 frame, and each frame has the potential to capture thousands of points in 3D space. We'll discuss frames further in a moment. You'll need to download the CREALITY Scan app in order to start scanning. It's available for iOS, Android, Macintosh and Windows. I've already seen a software update since I received this scanner, and it shows me that CREALITY are working hard to refine it. I found a couple of bugs in the first version I tested, but they got fixed in the update before I even had a chance to report them to the development team. The version I'm using now, 2.35, is pretty solid. 3D scanning is very computationally intensive, so you'll want a pretty powerful phone or computer driving the scanner. I first started scanning tests on a 2016 MacBook Pro, but the capture frame rate was poor, around 1 frame per second. That doesn't make the scanner unusable, but the Ferret has the capability to scan at up to 30 frames per second. And when I started scanning on a newer M1 Mac Mini, I started getting 15 to 20 frames per second, which made scanning much easier. The same applies when scanning using a smartphone. I use an iPhone 12 mini, but a newer phone will work better. I also have a Samsung Galaxy A23, but while not unusable, it's noticeably slow when scanning. CREALITY lists their hardware recommendations in the user manual. Let's do a basic scan to demonstrate the software. For this demonstration, I'll be connected directly to a computer rather than using my smartphone. I have my little Zen cat model for the demonstration. I also have this Lazy Susan turntable that I bought for $20 from a homewares store. It makes scanning a lot easier because you can move the model instead of having to move the scanner around. The little white dots were put there by me, but we'll discuss those later. I also have this Motorised turntable that we'll use a little later. When I launch the CREALITY Scan software, the splash page shows me that the scanner is plugged in and detected. If you don't see this, make sure the Ferret cable is firmly plugged in at the scanner and the computer. Press the Scan button to see the settings. Give your scan project a name. Mine is Zen Kitty. The folder path is the location where the scan project files will be saved. Object options are Normal, Face and Body. The option you choose here will help the software process the scan data. The scanning hardware is only a small part of the 3D scanning process, and the software plays a huge part. Giving the software a bit of a clue about what you're scanning helps the algorithms process the data and give you the best possible result. I'm not scanning a face or body, so I will leave this set to normal. Select the size appropriate for the object you're scanning. My model is around 150mm, which classifies it as small. Choosing the most suitable feature setting is the most important thing for achieving successful scans, and understanding this is very important. Scanning a 3D object is a bit like painting it. You start at a particular location, then you work your way around the whole object until you've scanned as much of it as possible. Each frame of the scanner returns a whole bunch of little points in 3D space, and as you work your way around, the software analyses the points and detects where there is overlap from a previous frame to gradually build on the scanned geometry. An object like this Zen kitty has lots of easily identifiable geometry, making scanning much easier. But what if I wanted to scan a bowl like this? The software is really going to struggle because the geometry is so smooth and symmetrical. It won't be able to figure out if I'm scanning this part of the object or this part. This is where the visible light camera in the scanner can be used to detect differences in the surface rather than the geometry. I'll demonstrate this further a little later, but for now we'll leave the feature setting on geometry. The accuracy setting gives the option for fast or high quality. The fast scan will process faster, but the scan quality will be sacrificed. When scanning a small object, high quality is the only option. Color mapping selects whether the scanner will store an image map for wrapping around the 3D object. If you're scanning for 3D modeling, you'll probably want this selected. If you're scanning for 3D printing, a color map is probably not necessary. If you're using a turntable to rotate the model, select Yes for turntable. So far, I haven't been able to discern any real differences in the results between selecting yes or no for turntable, but I assume it has something to do with the algorithm for processing the scanned data. At the bottom of the page is the option to import a historical project. This is how you reload an earlier scan back into the CREALITY Scan software. There is also the option to import a project from a smartphone, which we'll cover a little later. Now I'm ready to scan, so I'll press the New Scan button. The top left is the visible light camera image, the bottom left is the infrared. There is the option to manually set the exposure, but I've found the auto exposure works fine. If you see red appearing in the infrared image, it indicates it's overexposed, which often happens if the scanner is too close to the subject. There is an indicator showing whether you're too close or too far from the object, so you'll want to keep a close eye on this while scanning. It's very tempting to want to hold the scanner closer to the subject to try and get a more detailed scan, but it doesn't work like that. If you're having trouble scanning, I recommend pulling the scanner further away so you can get more geometry in a single frame. You can see the point cloud in the main window. It displays in green when it finds geometry it can scan. When you're ready to start scanning, press the Start button. You can see the frame and point counters here. The frames are the number of individual scans that have been captured, and the point count indicates how many of those little points have bounced off the object and been recorded as 3D geometry. You can see your model taking shape in the main window. When the model has a reddish hue, it means that some geometry has been identified, but it hasn't yet recorded enough points to fully resolve the shape. You need to keep scanning over that area until the model changes to green. I mentioned before that the scanning process is a gradual building of the shape, and as each frame gets scanned, the software identifies how it expands on the existing geometry. If you happen to move too fast or at an angle that's too acute, you may end up with the frame showing in red and reporting this error. This means the software can't figure out where this latest frame fits in with the rest of the geometry. When this happens, point the scanner back at an area that is already coloured green, then gradually work your way out again. Getting good scans does take practice. You'll get a feel for what you can and can't do, and what scans well and what doesn't. You may find yourself re-scanning an object 2 or 3 times until you're completely happy with the result. The important thing to remember is that you will get better and faster at scanning the more you do. It's also worth mentioning that some shapes will scan better than others. I'll go over the various limitations later in the video. When you're happy with the scanned result, with as much of the model showing in green as possible, press the Complete button to view the raw capture. There is a limit to how much data the software can hold prior to processing. When you reach that limit, it will display a message telling you to press the Complete button. I find that I can get around 3,000 frames before the message appears. Don't worry if you haven't completed your scan. There is the option to scan an object in multiple parts, then join them together, which we'll cover later. Once the scan is complete, you can view the results here. While the surface of the scan may look solid, zooming in will show you it's actually made up of points. Blue shows the outside of a surface, orange shows the inside. There is a one-click process button, which is what I recommend. You can always customize settings later on. Processing will optimize the points, turn them into a point cloud, and then into a wire mesh. Then it will add the surface map image to the geometry. This may take some time depending on the speed of your computer. When complete, you can toggle the surface map here. Some lighting inconsistencies during this scan have resulted in the top of the kitty's head looking a little funny, though I'm not fussed about this as I'm only interested in the geometry. If I wanted to, I'm sure I could resolve this by rescanning. I'm pretty happy with the end result here, but you can see I've ended up scanning a lot of the turntable, which is not part of my Zen Kitty model. So I want to get rid of those unnecessary points. On the project board, you can see my Zen Kitty project here, and you can see 4 items underneath. The first is Origin. If you click on the little closed eye icon next to it, you can view the raw scanned points. Click on the eye next to the point cloud to view the process and optimize points. Click the eye next to Mesh to see the wireframe created from the point cloud, and click on the eye next to Color to see the image mapped onto the wireframe. I'd like to remove some points from the model, which can be done from the point cloud. So click on the eye next to the point cloud. You will see some tools appear at the bottom of the screen. We have the option for a square or a freehand selection. We have undo and redo buttons, and we have a little trash can which will delete any points we have selected. There are also on-screen instructions indicating shift and left mouse click to select points, control and left mouse click to deselect points, left click rotates the model, right click pans and scroll wheel zooms. I want to get rid of these points down the bottom of the scan, so I'll line up the model so I can do a selection and remove all of them in one go. I'll use the square selection, shift and left click the mouse to draw around the unwanted points, which highlights them in red. Now I'll press the delete button to remove those points. I can undo if I change my mind, or redo to restore the change. I'm now pretty happy with the end result, so the next option is to redo the mesh from the updated point cloud, which you can do with this button here. Rather than use auto, I'm going to select manual, because I have a small issue if I plan to 3D print this model. 3D models for printing need to be manifold, which basically means they need to be solid and without any holes in the geometry. Well, as you can see, I have a huge hole at the bottom of my model where I was unable to scan. Now I could scan the base separately and then join into a single model, but I don't really think it's necessary as it's pretty much a flat surface anyway. Instead, I'll click the manual button and select Fill Holes and Closed. This will ensure the output will be a manifold model, suitable for 3D printing. I also have the option to force a limit on the number of faces if I want to reduce the model complexity, and the option to denoise, which will smooth out the surface. I want to retain as much detail as possible, so denoise will remain off. Press the mesh button to redo the mesh using our manual settings. Now we have a solid scan of our Zen Kitty. Press the export button to export the model. You can save it as a polygon file, STL, or wavefront object. These options will only save the geometry and not the color image map. If you want to save the model with the color image map, click on the color mapping button to reprocess the image map for the new wireframe. Then click the export button. Wavefront object is the only file format option when exporting the model with the image map. I'm planning to 3D print my scan, so I'll select Mesh, then I'll export as an STL file. I'm going to print the model to my CREALITY K1 3D printer. The K1 is a super quick Core XY printer and should make fast work of this print. I've sliced it in CREALITY Print, added some supports for the overhanging pores. Now let's print it. I lost one of the supports while printing, but it still came out fine. And here's the finished product. The original had some very fine detail, and some of that has been lost, but on the whole, I consider this a pretty impressive 3D scan. For my next scan, I'm going to make full use of the Ferret Pro and take advantage of the portability. This is my 1970 Dodge Phoenix. They were sold as a Plymouth Fury in the US, but there was very little awareness of the Plymouth brand here in Australia. So they were built here in Oz as right-hand drive and branded as a Dodge Phoenix 400. I want to have a go at scanning this Phoenix badge on the side of the car. I did attempt this earlier with the features set to geometry, but the scanner kept losing its bearings because of the flatness of the car panel. So this time I'm going to set it to markers, and I have applied these adhesive white dots to the panel of the car. The scanning software will be able to use these markers to accurately calculate the position in 3D space. I then attempted the scan when there was strong ambient sunlight, which hindered the Ferret Pro's ability to detect the infrared. So I waited a few hours to scan in the afternoon when the sun wasn't so bright, and it worked well. I found it quite difficult to see the results on the phone screen, but that says more about my eyes than anything. I scanned over the area from a range of different angles, trying to get a clean capture of the geometry. Now that I have the scan on my phone, I want to inspect and edit it, which isn't very easy on this little screen. So now I'll transfer the files to my desktop computer. To do this, launch the CREALITY Scan app on your computer, then press the Scan button. Now press the Import from Phone button. The software will display a QR code. On your phone, launch the CREALITY Scan app and tap the little share icon under the project you want to transfer. Press the Export to Computer button, then the Scan QR code button. Use your phone to scan the QR code on the screen of your computer. The project file will begin transferring from your phone to your computer. Looking closely at the scan, it's a little rough around the edges. I suspect this is because of the reflectance of the metallic badge. I think I would get better results with some 3D spray. Having said that, this scan is definitely good enough to use as a template for re-illustrating this badge.
3D scanning has come a long way, but there are still limitations. Firstly, you can't scan objects that are either reflective or transparent, not without coating them with something first. You can buy 3D scanning spray, which will put a temporary coating onto an object, improving its scannability. You will also struggle with flat items. If I try and scan something like a pumpkin, its bulbous shape works really well for scanning. But if I were to try and scan something flat, like this ornament, I'll be able to scan the flat face. But as I move the scanner around to the side, the geometry gets too thin, and the software loses track of where it is as I try and transition to scanning the other side. The scanner also sometimes struggles with holes in an object. The sensors will have trouble picking up the LiDAR in strong daylight, so if you're scanning outdoors, better to do it on an overcast day or when the sun is low in the sky. Not too dark though, or you won't get good results from the visible light camera. If you've been considering buying a 3D scanner, I can highly recommend the CR-SCAN Ferret and Ferret Pro. I'd like to thank CREALITY for sending me this 3D scanner. I received the scanner for free, but I've not been paid for my opinions. If you would like to buy one, there are links in the description. Please like and subscribe, and thanks for watching.
Please look out for part 2 of this video, where I'll be scanning a symmetrical object using markers, as well as scanning an object in 2 parts, then combining them into one using the CREALITY Scan software.